Okay, thank you everyone for coming to the Dallas Personal Robotics April meeting. I want a special welcome to the folks from Sensory Robotics who very kindly offered us a whole bunch of robo-mowers, and we have gave us a bunch of parts for them, which we'll have a giveaway for later, motors and which could be applied to any kind of a robot. And if you take a motor, be sure and take a wheel, because they like they mesh together nice and easily. It'll be hard to replicate. Okay, so today a couple announcements. Roboama, and by the way, may I say it's good to be back. I spent 3 months on a sailboat sailing between Thailand and Egypt, and sort of managed to be present for some of DPRG, but it's good to see you all in person and to like live in a real house and not a cabin. But announcements, DPRG announcements. Roboama will be next meeting, so fourth Saturday of May, which I think is the 25th. We will have 23rd. All right, thank you. So we'll have the competitions. We'll have quick trip, an advanced version of line following. Doug, do you want to talk about what advanced means?
Okay, well, DPRG have 3 levels. The simple one only has straight lines and 90 curved 6-inch radius turns. That's all it has in it. In the advanced, you have some additional elements. You have a segmented S curve. You have a 90-degree turn. You have a gap. And I think that's really all there is. There might be one other element.
Okay.
But so it's, to be quite honest, about 80% of the robots that can do the simple can probably do the advanced. The biggest element is the gap, because it breaks the rule of turning into the lost curve. Okay, but other than that, it's
cool.
And then there's the 3rd level, which we build up energy in the club to attempt the challenge course, and then after everybody kind of like blows their energy failing, then it takes a while for us to rebuild that energy again. So that one's going to be probably in a couple years. Anybody can challenge the challenge course anytime. We'll pull it out and we'll put it on the floor. If you're ready, we'll do it.
That's a challenge course that takes the steam, takes the wind out of everybody's sails.
Nobody has successfully completed.
Wow.
Except in simulation. Now, this is a good rule. In simulation, it's been beat many times.
Oh, but not in real life.
Not in
the physical world.
Yeah.
Okay, thanks.
You can simulate a frost for that, don't you?
Well, they probably point towards the use of advanced sensor arrays to actually solve the problem.
We'll also have barrel racing. We only had 1 entrant to barrel racing last Roboama.
We had 2.
Did we?
Yeah,
Oh.
Green was
But
he was doing that to make it a contest as opposed.
Oh, that's right. Yeah. So anyway, that's pretty fun. And I know Mike's got a real strong entry here.
Yeah.
Oh, great. And 6-can and 4-square we always have, and they're great competitions. And Sumo is, we hope to have some worthy competition for Scott, but you have to be real worthy to beat Scott. Let's see, what else? So today we are fortunate to have Sensory Robotics giving us a talk about what they're doing and a demo of their Unitree GoTo robot, which I'm very excited. I saw it in you guys demoed it When I visited your office, it can do some unbelievable things. So that's pretty cool. Very excited about that. And then after that, we'll talk about the giveaways. So the giveaways really are related to the robotic mowers, but particularly the motors are of general use for any like sizable robot, lawnmower size kind of robot. The thing that, and there's two styles of motor in those boxes there, one with an encoder and one without. The ones with the encoder have the 6-pin Molex connector on the back. If you take a motor, and they're free, you know, take what you think you'll use. Don't be greedy. Don't be a hoarder. But yeah, they're for anybody. If you take a motor, take a wheel, because that'll make things much easier, make your life much easier. The ones with an encoder, note that they have a single channel encoder, not quadrature. But other than that, I mean, they work fine. I tested a whole bunch of them. And then there are brushless DC motors, which are blade motors on the robotic mower, but you know, they're for general use. And I have put up a document on our Mowberry. So we've got a Mowberry project going on among 4 of the club members to build an RTK-based robotic mower, and David Melbourne kindly guided us to and gave us some of the parts that some of the drivers that use for them, and they work great. So, and they're cheap. They're like $11, I think, on AliExpress for the BLDC brushless DC motor controllers. So they'll be like real strong, powerful motors if you want to go brushless DC. What else about the giveaways? There's also parts, you know, LCD panels for the mowers. Really, probably only might be interesting for parts, or if you have one of the mowers. Anything else? And then we'll have a show and tell, and then we'll wrap up the main part of the meeting, right? And we're going to have a board meeting after that. Anything else? Any announcements?
Pizza at noon.
The what?
Pizza at noon.
Pizza at noon?
Yeah, so I've got a demonstration of Sumo and barrel racing.
Oh, cool.
Yeah.
Got both.
Yeah.
Excellent. Okay, well, with that, I'm going to hand over to Ross from Sensory. And
yeah, let's see if I can share my slides.
Yeah. Ross, come up here so the microphone.
Oh, you want me up there?
Yeah.
Right.
We can put your laptop next to it.
Okay. And, yeah, we need to figure out how to do that.
Yeah.
Let me how to do that.
Sure.
So,
Perfect. All right.
let's see. That's the slide deck. I need just need to show me how to.
Yeah, it might be easy to do the entire screen, maybe.
Okay.
And then change to it.
And select it and then say share.
Yeah.
All right. Hopefully everyone can see that.
Yeah.
All right. Good. So I'm Ross Melbourne and Sensory Robotics. I'm a co-founder with my brother David Melbourne. I'm a software guy, he's a hardware guy, and together we make one smart guy. So, and I think that we basically, I want to tell you a story of why we started Sensory Robotics, why we started with robot mowers, and then why have we moved on to an exciting new mission. I want to show you that. We're also joined here by Isaiah and Akshu. These are robot engineers. These are guys where the rubber meets the road. They're hands-on. They're both hardware and AI and software. So we'll hear a little bit from them as well. You can so basically, if you have detailed questions, they're the guys that can answer it. David can answer all the hardware questions. So, so where did we come from? Why did we start? We started with this. The Roboamo platform that many of you have came to us, we had an opportunity to buy over 100 of them, and because they would explain they were broken. Roboamo got bought by MTD, and a lot of times in those kind of transactions, that engineers are pushed too hard. Sounds familiar, right? And a mistake was made, and it kind of bricked a whole family of robots. And so we were able to get those robots, and David had the idea of making them smarter. So let me play this video so you can see what these robots do. So we put an RTK brain into it. We wrote some software which allowed them to work as a team, a swarm robotics, and they're doing striping very efficiently. So we've got 2 granted patents on this. We have 2 patents pending on this. And it basically was something we wanted to sell to landscapers. So there's 2 dominant robotic mowers. Dominant's the wrong word, but the most dominant robotic mower is the stay behind mower that like the Roboamo was, which has a docking station. And now the China has kind of dominated that market with wireless RTK systems with vision and the stay behind systems. And I've actually had 5 or 6 of them at this property mowing. And as of like 2 weeks ago, I've abandoned that completely. I've gone back to a landscaper to cut my grass. Why? It's because when you're dealing with 5 robots, every week one of them stopped. And the way out here, I pointed to David, look, there's a robot mower, one of the last ones that's running. It's a Segway, and it stopped. Stopped for all kinds of reasons. So the technology for these Chinese robots, it's pretty impressive, but you have to maintain it basically. You have to every week you have to do something with it, and that's fine if you've got a small backyard, but I don't. So anyway, stay behind, and then there's the stay with crew robots. This was designed to be a stay with crew robot. So this is our platform 1, and then we moved on to platform 2, which is again a stay with crew robot, which means the professional landscaper would take the robots with them and deploy them. And so, and you see the robots they're stacked vertically in the van, so they can take up very little room. And let me move looking forward for a little bit. So they're dual mode, so you can run them manually as well as you can run them as a team or a swarm of robots from just an app. And so the good news is, while we have kind of pivoted to an exciting new mission, which I'll share with you, we've been asked to sell an exclusive license to this technology. So it's not like we've abandoned it. We think there's a way to monetize it, but the challenge with this was landscapers needed to have it today, and we needed to find a manufacturer for it. And the manufacturers, a lot of them are overseas, and they take a long time to make any decisions. So as a startup, we want to move quickly, and there wasn't a lot of funding opportunities for this. But David built all these prototypes. Isaiah and I built most of the software, and it was a pretty impressive system. So, and this would stay with crew, and it can really automate a lot of the mowing. So the next up, I can stop that.
So were those mowers based on like an Ego or something?
Yeah, those are the original. The 22 inches are LM2206s.
Okay. How do I go to next? There we go. Okay. It's like that's the only thing there. Okay, this explains the pivot. So remember I said that I have to get rid of that window. Remember I said that it's hard to get funding, and the reason why it was hard to get funding because we had specialized robotics that did a single purpose, and they said, okay, well, we could see how this could grow eventually. 3 or 4 years from now, it could take off, and then it might grow. And but this thing happened along the way called humanoid robots, and in the robot community and the conferences I went to, they were a little bit of a joke at first, and everyone talked about the the H word. Don't mention the H word, because all the money was going into humanoid robotics, and when I say a lot of money, it's a lot of money. I would say in 2025 and 24, 90%, 95% of all money raised went into humanoid robots and self-driving cars. Period. There was almost no money left over for any specialized robotic systems. So Figure, Actronic, and Boston Dynamics are probably the big names, and they raised a lot of money. So why did this happen? What is it about the hardware that made it special? They're using actuators, harmonic actuators sometimes, and they're quite strong at times. Most of the Chinese ones are quite weak. So why did this happen? And what happened was the software, the AI, in particular physical AI, happened. And so I'll talk to you a little bit about what we learned about physical AI. For some reason, I'm hitting buttons and it's not forwarding. Let's see.
Press that hide button at the bottom.
Right this. There you go. So, what we decided to do was, okay, could we build our own robot, and could we benefit from the AI, physical AI software? So we are building our own robot, and you're the first people to see this. This is in Uri. It's in simulation right now, and in a moment I'll show you some of the pre-construction versions of it. It's a wheel-based robot. It's bimanual, means that it's got 2 arms. And this first version is just intended for research, meaning universities would buy it, and other companies like us that want to experiment with physical AI would buy it. So David is designing the wheelbase, and I can show you kind of in the next video what that looks like. The arms are actually from a company or open hardware called Open Arm, and show you this next video. Okay, let's go down here. I think it's because I'm on the the screen sharing that it's slow. So this is using what's called a VLA, a Vision Language Action Model, and vision language action models are kind of an extension of large language models, but and large VLMs, which are vision language models, and they add the action on to control the robot. So what's happening here, if you see you give it a prompt, pick up the screwdriver and place in the blue bin, and this is Isaiah's work. This is Isaiah did all the training for this, and pick up the screwdriver, and the screwdriver's in a different place every time. Sometimes the bins are in a different place. Now it's asking to pick it up, put it in the yellow bin. So this is where the kind of the language part comes in. You give it a text prompt, and it would do that task. And so we took a VLA, a Vision Language Action Model, and in this case it was XVLA, and we fine-tuned it. How many people here have done any kind of reinforcement learning or imitation learning or supervised learning? How many people have done supervised learning? Yeah. So really what this is doing is supervised learning, but with the transfer. We're doing the transfer learning part, which is a fine-tuning to our robot embodiment. And these VLAs are the reason why all that money got raised. It's not the hardware necessarily, the robots. So that is getting better and better, but the underlying physical AI, the bottom of it is these vision language action models. So if you said, why did ChatGPT explode onto the world? It's because of large language models. For this, it's VLAs, vision language action models. So I'm going to back up here and show you what else we've been working on. So why the dog? Well, one of the things that we noticed was that one of the things that hadn't been automated yet was the last mile delivery. And how would you automate that last mile delivery? Well, you could use a quadruped to get up steps and go across any terrain. And so we bought this quadruped to do this, which was do the package delivery. David has a new version of this package delivery that doesn't just drop out the back. The new version drops out the side, and I'll show you a video of that. So it does the package delivery and then goes back to the van. But the thing is that you can't really automate enough with just the last few hundred feet. You need to take the driver out of the van. How do you take the driver out of the van and have an autonomous van? Well, you need something in the back of the van that can pick packages up and hand it to another robot to take it to the curb. And so this is called pick and place. This is an earlier version of what Isaiah did to pick up a screwdriver and put it in a single bin. Notice the screwdriver's in a random place, the bin's in a random place, and it can always find it and put it in. So that's actually done with teleoperation. We'll talk a bit about teleoperation. This was done purely in simulation using NVIDIA GROOT. So NVIDIA GROOT is another vision language action model, and this one was done using a Quest 3 headset using the controllers to basically have it grasp a virtual steering wheel, pass it to the other hand, and put it into a bin. And another intern did 15 episodes of that, and then using NVIDIA's software scaled it up to 1,000 episodes, and that was done in inference. What you saw there was the robot running in simulation in inference, and here's Yuri again, just being manually controlled. So a lot of times you see robot demonstrations, and they're not really terribly upfront of whether it's teleoperated or inference. So this was teleoperated, and the pick and place we showed you, that was inference, which means a neural network is actually a policy is doing that. So one of the things, our goals are to move to wheel-based humanoids that can again load the van and eventually take the packages to the end. So we do have one warehouse prospect which does a lot of what's called a 3PL, which is third-party logistics, and they basically have to go around these large warehouse, picking up things out of racks, putting them into bins, and then wheeling the thing over to the pick and pack place where they take them out of the bins, put them in a box, and take the box up. So this is happening, millions of times a day in the United States, and it's all done. Almost all of it's done by humans. So this is the opportunity we have. So I want to show, because David worked really hard on the next version of the robot, I want to show you this. This is the new hopper on the back of the quadruped, and after this we'll actually show you a demonstration of the quadruped in action. So this is David's new hopper. We have the robot crouched down so it's closer to the ground, and then it can basically tip the package gently onto the ground with less room for it to fall and break anything. And so and the quadrupeds are uniquely stable, and with wheels they can move very quickly, and you'll be able to see how capable this is. So the last thing I want to show you is a little bit about the future of where we're heading with all this. So I told you we're building Yuri, and this is an example of Yuri built by Hugging Face. And this video basically shows the same set of arms that we're working with, and they trained it to fold a t-shirt. So for whatever reason, this is one of the hardest things in robotics, is to deal with cloth. It moves differently every time, and it's always in a different place. But they did, with a lot of training, they were able to do this. So this is 8 times not speed, but this is inference. This is not teleoperated. But to do that, they had to do a lot of teleoperation. So I think here we can see them. You can see them teleoperating the robot, and that they had to do a lot of training to do that. And so that's where we're trying to get to. We're trying to get to that level. And that was using a vision language action model called Pi 0.5 by a company called Physical Intelligence that came out of Stanford. And they've raised over $1 billion, I believe. And for basically for physical AI. And the latest version they just released is called Pi 0.7. Now, I say they released, they've announced it. And basically the amount of fine tuning that my guys have had to do to try and get any of these VLAs working is like 100 episodes. So it takes hours and hours and hours to fine tune it, to do a very simple task. And as the tasks get more complicated, like if you wanted to, pick up the screwdriver from that table and bring it over here and put it into a box, that adds another complexity to the task. And so the training kind of goes up and up almost, I wouldn't say exponentially, but it's a lot of training. So this Pi 0.7 is what they call zero shot. And I don't know why they call it zero shot. Perhaps somebody knows why. But it's more like 1 to 10 shots, which means you only have to train it like 1 to 10 times of what to do, and it's got it. And it's because it's a little bit like the large language models. How can it kind of imitate intelligence? It's because it's got almost every bit of text on the internet in its memory, and it can predict almost everything. And so what they found with enough training on these vision language action models, it can actually do something like, take out the trash and even put the trash bag back in. And what is very impressive is, notice it's 8 times speed, right? It's very slow, but it's getting there. What's very impressive is they can train it, they can show it how to fold a t-shirt on one robot and take it over to a completely different robot that's never folded a t-shirt ever. So the VLA has never seen that robot, and it can, without even showing it anything, it can fold that t-shirt. That's what they mean by zero shot, I think. And the last thing there, you saw it with an air fryer. They call this, instead of fine tuning it, they call it steerable. And the reason why they call it steerable is because the guy is giving it verbal commands. It's never seen an air fryer before. It doesn't know what to do. And it's saying, with your left gripper, pull the tray out. With your right gripper, grab a sweet potato, put it in the pan. Now close the drawer with your left gripper and hit the start button with your right gripper. And it's literally, you can watch this video on your own. That's what he's telling it. And it's never seen this before. He took it out of the box, and it's doing it here. It's like grab it and open the fryer with the left gripper. And in effect, what he's doing with verbal commands, he's fine tuning it. And then after he's done that, the robot can do it on its own. All you have to do is say, put a potato in the air fryer for me. So that's the promise of it, right? It's 4 times speed. So I'm not gonna overhype this stuff, right? This is not human level performance. But think about this in a factory setting. Really only the robot can work 3 8-hour shifts in a row without stopping. So if it gets to 1/3 of a human speed, then it can match a human's output in 8 hours. As soon as it gets faster than 1/3 of a human speed, it's now more productive than a human. And the bigger AI calls this infinite labor, which means if you want more workers, you just add more machines and it'll do that. So that's why the robot world is so excited. I did a little bit of research. It's the last 3 years, $30 billion has been spent on robotics in the last 3 years. In the previous 25 years, it was 60 billion. So in 25 years, 60 billion, 3 years, 30 billion. It's just incredible how quickly it's going. So with that, I'm going to pass it over to Akshu.
I have a question.
And you ask questions, and Akshu, perhaps you can get the quadruped ready.
You know, in this last video you showed where he's giving it voice commands, wasn't there some underlying training so that it knew what an air fryer was and it knew what a sweet potato was?
No. I mean, they didn't specifically say, it's never seen an air fryer before. It didn't say it's never seen a potato before. But it's built on like a large language model, right? If you ask a large language model, what is a sweet potato? Has it been trained on that? Well, kind of, yes, because there's millions of lines of text out there talking about vegetables and some of it. So because it's a vision language model, okay, so there's vision language model it's been trained on lots of visions of things. So you can bring it out here and start doing demos. Lots of visions of things. So it probably does know. And what they've done is they've labeled, here's a picture of a sweet potato, and here's the label of sweet potato. So to answer your question, it has been trained on that.
That's almost like an inherent thing.
Yeah.
Or just an inherent model.
That's right. That's what
So, should I talk about it?
please, go for it.
So this is our GoTo. It's made by Unitary. Just a quadruped dog with wheels at the bottom instead of like actual feet, because it's actually easier to navigate and move around the world with wheels rather than feet. I believe the top speed it can go unregulated is about 17 miles per hour or something like that. But there's some limiters in place normally because it's going to hurt if you get hit by a 17 mile per hour dog. And this is pretty heavy. I would say about 30 pounds or so.
It's going to hit the chair instead of you.
Yeah.
It won't. Hopefully, Archie will.
I'm not going to hit the chair. I don't want to. I don't want to. But inbuilt, it has a couple of cool tricks like it can climb up boxes and stairs. Actually,
why don't you do the first two tricks?
Okay. Yeah. So we can actually do a handstand with the dog. So let me just turn it.
Excuse me.
Yes.
Could you kind of like go over the sensors that are on it? Point out, it seems the problem is the LiDAR. I always thought it was a flaw.
No, there's a LiDAR, and in terms of other sensors, it has a gyroscope. I believe it has IMU, yeah.
It's also on the camera.
No, not this camera. There's one IMU internally, a gyroscope, and anything else, Isaiah? Do you remember? Sensor? Yeah.
It has current sensors.
Yeah, it has current sensors in the wheels. So actually,
What is the little thing on the top of the head?
that's another camera.
Yeah,
There's two cameras, a depth camera and the normal camera on the dog face of it, I guess. Yeah.
Make it do a handstand.
Yeah, I'll make it do a handstand. Chair over the way.
No. I know what it could run into his legs.
Oh,
Yeah. The thing about these things is they're inherently unsafe.
yeah.
They look like they're safe and they're controlled, but they're not. I'll tell you now, you don't want to get close to it. Yeah. Because it's heavy. It's much heavier. It's probably twice as heavy as you think it is, and it can move really quickly.
Yeah.
These are all pinch points. Always say safety third. Yeah, they've always joked safety third.
You don't want this to run over your foot. Trust me.
Is it voice of experience?
Yeah. So yeah, it can completely balance itself while it's doing the handstand thanks to its gyroscope. So and it can move around pretty well. It can't climb in this mode, but you can move this box and you can actually climb it.
Are you going to turn it upside down?
It's locked right now, so it won't open.
No. You can turn it. You can sit it on here instead of the wheels, because otherwise it's going to push the wheels. It's going to push it. Yeah. The wheels. Oh no. Okay.
So
You get over right in the middle.
well, no, it won't be able to come up. It has to.
It doesn't shed. Oh really?
It has to be.
Oh okay. It has to be this way.
Because we don't have big enough box, but it'll
You went sideways before you.
it'll kind
It
of
doesn't care. Okay.
yeah. So we got to put it into climbing mode. Climbing. Now, basically, it figures out it needs to climb what's measuring resistance on its wheels, and it'll come out like that.
Yay!
Yeah. But the better part, yeah. There's also a couple of attachments you can add on, like a gripper arm on top of that. You see that
Rail mount.
rail mount, yeah, and you can use that to grab things once you tell it to. And there's a lot of different attachments we can add on. We actually added a blower, opposite of that. Yeah.
Amazing way to do it.
Yeah, and the battery on it is great. I mean, if we're not doing any software on it, it'll last 12 hours uninterrupted, just running around doing whatever you want. Then once you start running software, because on that rail mount actually under it, there's a compute unit called the NVIDIA Jetson Oryx. Yeah. Then the battery life starts to trickle down into like 4 hours, 5 hours, depending on how heavy of a load you're running.
Can you make it the side step?
Oh, yeah.
Sideways?
You can sidestep. And there's some functions you can do with the other models. This model doesn't have it because it has wheels, where you can make it do some dances or backflips. And it's completely self-stabilizing, so I'm not going to do it. But there are videos online of people throwing them, and they'll just completely get back up from any position. We could even put it on its back. It could do that, like a upside down turtle, I guess. But yeah, there's a lot of different things we can do with this. And if you guys have any questions, feel free to ask. Yeah.
Is it a customized PC board or use off the shelf stuff?
The internal stuff is kind of a black box. We don't know much about it, but that NVIDIA Orin on top is it's just a off-the-shelf Orin. It has their own OS on it for Ubuntu, but yeah.
How come there's no pneumatic wires instead of solid?
I honestly am not sure. Do you know, David?
No, I guess the Humanoid has a bit more pip to it. Shock out it. I think the thing that's surprising on these, I hope it works in shafts once we lay it down, is to feel how heavy it is. It looks like it shouldn't weigh, but that weighs an awful lot. Yeah, which kind of helps in some ways.
There used to be a carrying strap on top. It broke because of the weight of the dog.
It's substantial. I'm not sure what the total weight is, but it's more than you think it is.
I would say like 50 pounds.
No, it's
Maybe heavier. Yeah.
Yeah.
I've never actually properly weighed it. It's just heavy.
I don't suppose that people at the airport love it.
So can you make it crouch down now?
Yeah.
Is it?
I can crouch it down.
Yeah.
So it goes. That's the lowest it can go with the controller.
Yeah.
Theoretically, if you put the feet out more a little bit, it can go down lower.
You're still moving around in that position?
No.
So if you make it stand back up and then crouch it back down again. So you see how it stood back up there. Now crouch it back down again. We won't do this, but if I was to take one of these legs and move it out, it's very unstable at that point. It stands up and it's just like it's lost its mind, and it can be, it's like very scary. So I had a capstone project with MutiB, students using this to experiment. We had it put a trimmer head on it to do kind of grass trimming, but I had to put them through a training course of how to set it up properly and how to ride it up to the safety, because when we first tried it, it's just like it's scary. It's like it's doesn't know exactly what the angle of its legs are. So you have to. These guys are expert in how they set it up, and it work every time. But it's far from. It's very much a research and development tool, not ready for prime time. Now the newer versions. This is about a year or so old. The newer versions might be better.
Yeah.
That doesn't auto calibrate.
No.
It doesn't know where its legs are.
Yeah, I mean that's.
Doesn't know where its legs are. So they're relative sense.
Well, that's the reason you have to put it in a particular position.
But when you kind of research the actuators, they have positional feedback. So I don't understand why they. so I
It might
did
not
talk-
be indexed though, so it's got to figure out where the start is.
yeah. And I,
Going through the limits or something.
yeah, and if I had to guess, I would say that if you had to have it do its self-calibration, that in itself would be dangerous, because then you've got to put it in a pen and make sure there's nothing around it. Like this little pen, that no one's going to do that. They're just going to hit the calibration and it'd be right there, and it could hurt them. So I don't know. I'm not. The Chinese are very impressive, but they just have no regard for human safety, in my opinion. And I spoke to the guy, a Unitary guy, about this, and I forwarded him to a presentation at one of the conferences, and he had a humanoid, G1 or something.
Yeah, it was a G1 Air.
And he walked it through the trade show, teleoperating it, and then he took it on the escalator, just standing on the escalator. That thing must be 60, 70 pounds on an escalator. It falls back. It didn't care. It's just like, and then he took it down the escalator. Lots of people in front of it. And 5 minutes before that, I'd seen a guy, and I can show you the video. I've got it on my laptop, of a guy very curious. We're all curious about these robots, and everyone pushes them. The Chinese love to abuse robots, and I told this guy, I never want you to see kicking this dog, right? Because to me, it could be a real dog. Don't do it. And they push these robots around to show, look how good they are balancing. But it's got a handle on the back of it, right? And it no sensors on the handle. So this guy was pushing it like that, and then he saw a guy grab it and pull it back into the trade show booth. And then this guy picks it up like this, and it hit him. Damn. It's really scary stuff. So you have to be very respectful of them, but they're incredibly capable. So you may stand up again. We'll do more handstand. Is there anything else? Can you make it do jump?
Not this model. The leg models can, but the wheel ones, they can't jump.
Yeah.
I want to ask you a question about, okay, it looks like it's got motors in the shoulders and hips, and motors in the wheels, but in the elbows and knees, there's no, it looks like it's just a spring. How is it? No, it's not.
There is a actuator in the knees.
No, I don't think they're knees. I think the actuator.
Yeah, I know it has to be.
The actuator is the hip.
The actuators are up, and then there's basically.
Wires.
There's one that like goes side to side.
So do you want them to?
How many degrees of freedom? What's the total degrees of freedom on this?
Yeah.
16 right now.
1, 2, 3. Someone knows. That's 4.
4 per leg? Does that include the wheels?
No, the extra 4 for the wheels. Software of it. I asked about Unitary. Did you use Isaac Sim, Isaac Lab, which is these tools to do these tricks? He said yes. So this is using reinforcement learning.
Yeah.
So it's learned all these capabilities using reinforcement learning. So when Archie tells it to climb a box over, it climb over the box. It's using reinforcement learning to do that, and it's done it in simulation first, and they move it from sim to real.
So does that low-level behavior run on the Orin or on?
No, it runs on an internal.
Internal.
Yeah.
The Orin is an extra thing we added to put our software onto.
Yeah.
But they don't make it very easy to kind of to put your own policy on there. We built our own policy in simulation for it, which is not as good as the policy it's got. But we wanted to see could we build a policy, a reinforcement learning policy, and put it on there. Yeah. You want to make a climb again?
Yep.
Wow.
That's why I said.
That's what you get. That's the example of it. Oh, he doesn't know what to do, and it's just starts thrashing.
That's why the box isn't like the greatest climbing example. Let me ask.
Yeah, it went sideways. Yeah, go backwards.
I'm up on the LiDAR?
Yeah. Check sideways, Ross. Stay safe. Yeah. Sideways.
Yeah, go backwards.
Sideways, Ross. That's not hurting.
Yeah.
Yeah, I think it's much worse.
Wow.
All right, so let's power it down so people can inspect it, because I'm sure you guys want to see what it's like. And so just be careful of these. If you touch it, just be careful of these pinch points here. But you can take the body like this and try and lift it. And it's kind of see how the action is. Well, if anyone wants to inspect it, we'll give you a couple of minutes to do that.
Yeah, what's up?
Is it brushless?
Sorry?
Is it brushless?
Yeah.
Yes.
And how much do we put in it?
We think
We
we.
advertise.
Yeah, it is heavy.
It is heavy.
No, it is heavy. You wouldn't think it'd be that heavy.
Wow.
Yeah, it's solid. I mean, yeah. Once his legs are like that, he's never getting rid of it. I can see there. Yep, that's it. He's now he's immobile. Did you guys put the camera on the next camera on the front?
Yes, the next camera is stopped.
Yeah, it is. We asked them to add it. So they added it.
They put it into the.
Just use so it has the crappy drugs.
I'm not sure if it's planetary or
Well,
psychological.
this is the new number one.
You can't hear the key. It's usually with planetary. Yes, planetary. It's a lump, isn't it?
About as heavy as that thing I carried.
Yeah.
That's all good.
Oh, that's the battery.
Oh, yeah, when you look at
Yeah, pretty much. Change them off. This is so cool. 332 watts.
Oh, it's just
This is from Unity. This is their
Because they
built-in,
use those arms.
You can run external programs.
And you can actually, add it all up, it starts to come.
I don't know.
Quite a lot. See, there's a lot of power in place, and actually have to build. These are your exit in Yes, we can come back. Okay, we'll have to know. You just have to go get charges.
How does it handle the transition? The battery, power goes down.
Inside the power, like this whole thing, so we put the it's basically, this is the same thing, but you're losing less than so you can change one back at a time. There's one here, you've got 100%. Obviously, it doesn't change both at once. That would be.
Yeah,
It would lift it up and stop.
okay.
Well, it's also a problem because there's so much. We also have over protection, under protection, so you can just like everything with that. Yeah, we try to avoid that. We have a sign that says, "Do not be on fire."
Yeah, it's inside there.
Oh, inside there.
Yeah.
And the reason why the delivery thing goes sideways is the other, there's actually another close to us, and they were just dumping out back to everybody still excited. But there goes the best China. I ordered these Chinese cups and they just smashed it. So their next version actually has like bomb doors.
Okay.
But then you kind of limited on what you can get out.
Yeah.
So I made our box able to hold, something this tall, it could weigh 30 pounds. I figured that would cover most of the package, short of you having a sugar.
Mark and I watched the Amazon drone drop a package from about 15 feet.
I've seen the videos.
Crazy.
And it's just a simple. In fact, in the front part of that box is the PC that does the uploading and all the rest of it, on top. So it knows how fast it's going and where it's going. And the camera. Yeah. The idea, of course, is the delivery.
Yeah.
At the same time, it's just trying.
Yeah, like you see that like little divot actually, yeah, handle will be there.
Eventually,
I don't know.
I think we don't have the size, like standard height. If it added or spider strip.
Also, it's like that's above.
Is it preferred like climb continuous stairs, 4 or 5 stairs? Like okay.
No, it's more like compact.
Like you've not tried to change the world so that
Oh yeah.
this just we didn't build like this.
Oh yeah.
I believe it's because they don't consider it
what else the big companies are doing it, like Google Robotics and stuff, and software consider the storage. They have already done the training. So there's a lot of things which are also.
So what is, just for curiosity, what is your weighing in right now? So
Other concepts like
tell me you don't want to run over your foot.
No, and the base actuation right now is two 10-inch. Geared brushless strategies are the best.
The LiDAR on that, they've got like 360.
I've only used it.
So you can visualize.
Yeah, visualize. The only time I used it was in a giant. I was in that UTV group. I was using it in our like lab area. It's like a giant room, so I didn't really do much. So I'm only going off of what I feel. But yeah, it can visualize the smaller area for sure. The lab art.
That's a lot of fun.
Oh yeah, I'm so happy to start to work on it.
Yeah.
It's one of the coolest. But honestly, the BLA stuff we're doing is also really exciting.
Yeah. I need to get into that.
Yeah, I would definitely recommend looking at the base of the robot community if you want to get started in it. They make training and all that super easy. And it's like just reading the papers. And they like it's so cool.
And who was that? Sorry.
The community I was talking about.
Yeah.
The robot. It's like part of something like their associate systems.
Okay.
They
Do they get up? Like literally the robot?
Yeah.
Yeah.
I think it's because they're friends.
Makes sense.
Yeah.
Sounds fancy.
So, like, the BLA.
Yeah.
Sorry, what was it?
Right.
Yeah, I'm on.
Yeah. So what's your next project for? What are you doing this time?
I'm not doing anything actually. Me personally, nothing. They're just trying to refine the what I made for it was cool. Definitely still need some more fine. If you saw that first video where the dog was squatting a little bit, that was me.
Yeah.
I mean, it squatted and it didn't. And your tag just didn't really survive.
It's not looking on the
Progress.
Because actually controlling the low level price was pretty difficult because of how unitary programs are. If you send low level programs, so turning off that
How long do they take to charge these?
It's from 0 to 80%.
It's pretty quick. I've done it. It charges to about 50%. It's like 45 minutes. So assuming an hour and a half.
I don't think he's getting up in this.
No, he won't get back.
you doing remote mobilization? So when you're regulating, I think it's valuable. That's where that's what actually makes the bias in the US are and all the regulations. It's nice to have because in order to get over any of the regulatory, that's securely impossible.
I'm honestly, I don't know.
Do you think we ought to reclaim this meeting and?
But I think they're refining the delivery. They're focusing more on the
11:15. We want to get some show and tells done. Seems like we've gotten into sort of like conversation mode at the moment.
Yeah. Well, I mean, it's.
I think we should try and get a couple of show and tells done before lunch. What do you think? Yep. Or
because we got money.
Yeah, we got right. And we got that thing.
Yeah. That's cool. Yeah, we stores online came in and we found animatronics. So
Yeah. All right. Let me just talk to Ross and see where he's at in terms of.
I think these are writing on it. Yeah, I think I'm a larger.
2206 is the big nose.
It's like down the street, like that.
It's a little spooky. I've seen 6 of them kind of taking years. Get out of the shop. Push the button. It's one. Once you get Comes up with that, right? It's probably gonna be.
Where do you get it?
Again, you're replaying the speech. Okay, can I have everyone's attention, please?
Oh, would have to be like 14 acres. Oh, yeah.
Okay, we lost a couple of people, but they'll pick back up.
If you guys have any questions about fine tuning, these two guys, those VLAs, these two guys are hands-on with it.
Oh,
So please feel free to ask them questions afterwards.
Yeah, we got that sense of sorry, guys. I mean,
it's a two-person job to rebox it.
Yeah, especially with the strap gun.
Awesome. Well, thank you, Ross, Akshu, David, everybody, Isaiah, and everybody. Yeah. Great demonstration, great talk, and thank you very much. We're going to, I think what we're going to do, we're going to just change the schedule just a little bit. We'll move right into show and tell because we've got a couple of good show and tells, and I think by the time that's over, pizza will probably be here, and you can pick away at people have been picking away at stuff already. But yeah, just have at whatever's in the box. You're welcome to. So, who wants to go first on show and tell? I think Mike's got one, and I don't know your name. Yeah, you want to show this? That looks really cool.
I can't bring it over there because it's connected.
Okay, well, let us slide out of the way.
Yeah, and let's see if we can get a little, at least a little video going here. Wonder.
Well, I'm gonna try Untitled. You can go to the next person.
Oh, you got to do something to it?
Yeah, I gotta turn it on and everything. It's gonna take a little bit.
Okay. Hey, Mike, you want to do yours? Are you ready to do your robot show and tell? Or oh, so we got a few minutes either way. So.
All right. Sorry.
Yeah, basically each board.
So is there really no way to fix that stopping with no signal? Is it in the firmware? Well, it's the yours.
Not very smart.
Are you not sensing the box or anything?
I sense it, but it's a front.
That thing scoots right along too.
Yeah, so the box is sort of heavy. I put rubber bands on it to give it friction. So it's a good obstacle to push. You're slipping. Change that.
Always something my mom.
Trying to push it.
You can almost break that.
Might be trying to film it.
I need more sensors on it so I can see one over there and push towards it.
Yeah, it looks like the sensor range is really short.
Yeah, and just basically the front, keep pushing.
Well, it's really good to kind of bounce it like that because you can get locked in and then lose traction. But if you back up and then hit them.
Yeah. Do you have any weight? Do you have any weight for that? Do you have any weight for that? No. I can see it's at 495. I went and did it. Wanted to do that room for additional. Different bill. I want to build a second one with like four dimensions. Like kind of like those yeah. It's a single point sensor. Okay, you ready? Yeah, I'm ready. Okay, so that's my little show and tell. That's right. I'll switch is the sensor. 6 fingers in the hole. Is it turned off?
Whereas the other one, you tell them
I get mine. So it's
but we have to go, we have to send it.
It's worth once a year.
You want to get us to talk a little bit? Tell us about this.
This is the Endoskeleton.
Endoskeleton.
This is the animatronic robot that uses for video games. So I thought, I always like to recreate things from video games or movies, and I want to bring technology to real life. So this is my prototype event of it. One day I want to make it to a little body-sized robot that can interact with different people with Raspberry Pi. It runs with a ChatGPT, well, a chatbot kind of algorithm. So it can interact with people, dance, sing, and activate their guests and say hi. And this is a prototype. I mean, it's not an actual robot that can do its own thing on its own right now, but it will perform. And it has like 14 servos to move to hold everything. And it took about a month to make. It's a 2 minute song.
We got time.
You have time?
Yeah.
Okay. But yeah, I animated all this. It took about a month or two. So I have 2 songs I made of this. So yeah. It's running a software called the Tango. This is like a 3D animated software for animatronics, and you connect it with the Arduino, and if you move it.
Will this Tango run on the Raspberry Pi?
Not currently, but I can run mostly all the Arduinos. You know, mini, mega.
It's running on the Arduino.
Yeah,
Okay.
it's a community project we've been working on for about 6 years. And have Discord, so you can talk about making it better.
You buy some of those arms that Joe was talking about for us.
I mean, I know this is like a personal robotic event, not an animatronic event, but I try to look for maker fairs, but this is the only I can find.
It's cool.
Thank you.
So the ultimate goal is to make the chat box out of it.
A full-size robot, I could walk everywhere, yeah. I could dance.
When you say walk everywhere, you mean legs?
Yes, legs. It's not gonna walk. Technically, it's more like a sliding mechanism. So it's kind of like a gear rack system. We go this way, with wheels underneath it. Kind of like an insulin robot. Which, because it makes it easier to maintain.
Yeah.
And also, it gives the look. Huh? Yeah, I made the flyers, they want them.
Cool.
And you can see more of my work on Instagram at what was it? Robot Art, and anyone can just follow. Anyways, that's it. Thank you. Thank you.
It's been a while since I've considered this.
Okay.
Yeah, I know how much
I think there's a reason for that.
Stuff I do is so boring.
Mike was gonna show us his
Yeah.
yeah.
Oh, no.
Oh, no.
Different stuff. Yeah.
Every time.
Now, better now than on May 23rd, right?
You're a little slow right now. It's gonna take a little while. All right, so.
Okay.
So if you're a DMS member, they have a couple of food trucks out back for the print, steam all the print thing going on, and they have food and Italian ice truck out there. We do have pizza coming here, so I recommend using our pizza. But if you need a ticket and you're a DMS member, I have some. Otherwise, Megan will have tickets as well. So get your ticket.
We don't talk about
Dessert or a meal. I'm not sure what the main is. Eloise's kitchen. I'm not sure what it is. That's dessert. On dessert or yeah, but yeah. Yeah, come do it.
But might be the conservative.
Yeah, we have pizza coming here. It's just for.
Yeah, you can pull it out.
No, I think that's. Do you remember? You member?
Thank you. Yes, it is. This is what it is. It's like a 3D animated software. It's open source. I have to say it.
No, I'm right. Get it out of the house. Looking at some other things. No, I just.
Okay, so for anyone on the video, this is the.
Where's the QR code?
I don't see one either.
Yeah, because it got overloaded now.
So anyway, no, they always flip it on the local display.
So it's a chapter.
Well, no, you switch it up on here.
I don't have the term.
And that was.
It's a little bit.
Yeah.
Oh, it's always a show, man.
Did you?
Yeah, basically, each number represents a different process or different.
I was looking.
I have a script for everything. So go to this section, seek a can. It's just this switch determines which one of those scripts gets loaded.
We got a lot going on.
Like I have one script for can, 6 can. I have another one for trim.
Sometimes the timeline before the pizza arrives.
No, it's not a subroutine. It's actually a script. So I have functions. Like I have a function to navigate. I have a function to compliment. I have a function to pick up a key. So then I'll write a script which says, okay, go get a can, go pick up a can, navigate to this point, pick up a can, navigate to this point, drop the can off, turn around, find a new can, and so like the quick trip, right? Navigate X, Y, this coordinate, turn around, navigate back. So it's really short. And like on the barrel racing, go to this X, Y, and run an R. That's the behavior I have to put in it to have it run an R. Define radius to it. So basically, I go to a big point or waypoint. I come run an R until I hit a particular heading, and run to another waypoint. Same thing, go around the cut until you get another heading. Then, going from the second to the third can, I had to kind of take a different approach. Because I'm mad at the angle, I actually have an intermediate point. And line up.
Yeah, you can fly.
So what's the
yeah, well, doing it, having that kind of script-based behavior-based thing is really easy for me to take. And actually, I had recorded this software here yet. I did it in I was testing it out. But now that I have the script, basically cut and paste the same script in here because it all follows the same structure. It's David's old subsumption control. So each behavior sets a flag, and then it goes through and it checks, okay, what behaviors have the flag said, what one has highest priority. That's what I'm going to tell them. All my robots run off probably 80% of the actually, depending on the hardware, like on my big, I use a different PID. I have better handling. It does change a little bit, but yeah, it's pretty much, you know, it's, I actually have building lines in there. Use the PID, use that PID. That's why. Yeah, well, yeah, I don't, there's no really telling on what it is. Just kind of a telemetry thing.
It's not. All right, I'm gonna try. Here we go. Thing is, there's not a rumor on that can. Oh yeah, we can put that back there. Thank you.
It doesn't look like a can. Let's go around this. Even those carrots back just a little. Yeah, okay. That's fine. Yeah, Ross has to boot up, so.
So tell us a little bit about it, Mike. So it's a Ross robot, right?
Yeah, it's a Ross robot, has a Raspberry Pi, a lot of sensors and a modem on it. And for some reason, my Pi wasn't connecting through the modem to my computer, so I rebooted everything. And my version of the so what can happen is it's going to come out on a planned course and point to the over here, and then it's going to check the camera to make sure it's pointing in that direction. Then when it gets closer, we'll use the LiDAR to detect the can. It'll go around the can and break out at 90 degrees, because it will just use odometry and keep track of its orientation. And then it'll go over here, it'll look for the can with the camera, and then look for the can with the LiDAR when it's closer and go around it. Same thing with that can. So it uses the sensors to detect where the cans are.
Okay.
So I can move the can.
The start line looks a little close up. It's
Oh, the
usually
start line should be here. This is just
that's just
4 feet from here. Okay.
I got you.
And the cans are 6 feet apart, so it's like the smallest course
Okay.
within the regulations.
So this is for the barrel racing competition that will be held at Roboama.
So this is the like this can be another foot out, and these can be 2 more feet separate, so they can be within that range.
Ahead. Barrel racing at the competition will be at 8 feet.
8 feet. So
It will be at 8 feet.
this is 6 feet. Yeah.
I know. I'm just telling you so that you can plan for that.
The competition master has spoken. This is how it will be.
The reason why it says 6 to 8, because we don't know what our remote people can do in their locations.
Okay.
And the space here was 6 feet, so yeah.
Exactly.
So I'm gonna hit the go button and see what happens. So when it goes around the camera, it sees the can off to the side with the LiDAR. So it knows to stay a certain distance away at a right angle to it.
And are you sandbagging the speed yet, or is this it?
I've been trying to speed it up.
Okay,
Yeah.
I'm just curious. I know that
Like, if I go too much fast,
some of these guys kind of sandbag things in the.
I like to eat that.
Be twice as fast.
Like, where's the sound system so we can say yeehaw?
Right speaker on it. Looking for the right a small speaker.
Yay! Gold star for Mike.
So hopefully it'll be twice as fast. That's my objective.
Awesome.
You have that on your.
Not in here, in number 9, I didn't.
Okay.
I haven't ported it in here yet.
Okay.
Hey, a question, Mike. You were showing your Sumo robot pushing the block around before, but you want to talk a little bit about like what's in it, the electronics and what's inside it?
Well, it's on my GitHub site, Mike W123 GitHub under MS26 for Mini Sumo. So it's all documented. I'm not going to take it apart.
No, obviously not.
If you want to see the insides, go look on the
Yeah.
on the GitHub. But this is the trying to get the camera.
That's all right.
Yeah, so this is the competition size here, which is 10 centimeters by 10 centimeters. And I weighted it to be 495 grams because 500 is the limit. And the heavier it is, the better. And so I use these Mini Sumo wheels right here. And those are really good silicon wheels for traction. And on the side, I have my batteries in here. Let's see, I'm not going to pull it out, but the batteries inside there, and these are my on-off switch is just connecting the cable and sticking it in there. And the electronics, the brain is the RP2040 micro. You can see it in, you can't, it's too dark, but it's in there, and I have time of flight sensor in the front, so it can. That's what says. Oh, there's something there, so it keeps pushing.
Is that like one of those 8x8?
No, it's just a 1x1.
One by
Just
one.
just
Okay.
single
Yeah.
point.
Yeah.
I want to upgrade it to 8x8s on all 4 sides, but and these are IR sensors here, but they don't work that great. So, but they're there to give it a little angle control. And so if I turn it on, I'm gonna. So you can see on the inside there's the lights that come on, and I'm using this sensor in the front as my on-off, as my go switch. This is the on-off power switch. So if I hold my finger on it, then 5 seconds later it'll start spinning. Right. And then I use this to disconnect. So I'm just using the sensor as my stop and go switch.
Gesture orientation, right?
Huh?
It's gesture control.
Yeah. Stick your finger in there. You have to stick it in the hole to do it, so it doesn't accidentally turn off when the robot hits it. Yeah.
Do you want to show it like pushing because you didn't really have the focus of the meeting when you were showing it pushing the brick around.
So for competition for Sumo, you got 2 robots, and then you're supposed to go. Then coordinator says, start your robots, and everybody. 5 seconds. And when you lift your finger away, 1, 2, 3, 4, 5. So there. So right now there's nothing in line, so it just hits the edge.
So is it using the front-facing IR sensors at the moment?
Two sensors on the bottom.
No, I mean while it's looking for targets, is it using those forward-facing IR sensors on the sides?
Mostly the time of flight.
Okay,
I
then.
tried to use the IR sensors to say turn a little left or right, but they're not that like.
Oh, so
It's easy to be invisible. On IR sensors point of view.
Oh.
This says, oh, there's a robot right in front of me. Just keep pushing.
That's awesome.
So I hope I can be competitive. It's not very simple. Yeah. And
Scott, are you feeling worried?
Second place to me, Mike.
yeah.
The sensors are on the bottom, so it doesn't go off.
Oh, they're two little IR sensors, sort of like line detect sensors. Yeah, and then the code in it is really simple. It's like Python. It's a OSC code, and it has like I can't remember exactly, but 10 states. Yeah, so it's just a state machine runs in a circle. So it's really simple. I love it. That's cool. Try not to make it too complicated.
Yeah, that's the fun thing about Sumo. It's not that complicated.
Okay. All right. Thank you.
Thanks. Well, since we got 10 minutes,
Do it. Never mind. It's already here. Where's it go?
oh, pizza's here. All right. Okay, well, we'll declare a break for lunch, and I don't think we have anything else. The pizza, and so everyone feel free to hang out, chat, eat pizza, go check out the printing press, Makerspace steamroller printing press, grab parts, and we'll call the meeting done. And for as long as but as long as you want to hang out, we'll be, we got the room till 2. Okay, Pat?
Yes.
So I think we're going to call the official part of the meeting over now. So, shall I call you?
Hey, Carl.
Shall I call you when we get ready to start the board meeting?
Yeah. Do you want to send me a message or whatever when we're going to start the board meeting?
Say again?
Do you want to call me or send me a message when you're going to start the board meeting?
I can send you a message if you want. Either way, let me check if I've got your phone number.
I'll email it to you, Paul.
Okay, I don't have your phone number. Let's see. You can message me if you want on Discord with your phone number. I feel like I should have it. And then I'm imagining probably by about 1 o'clock our time, we'll probably be ready to start the board meeting, if that's okay with you. Oh, got it. Great. Thank you. But you know, I don't want to keep you, want to be respectful of your time on the sad day as well, and not have you hanging on around here watching people eat pizza.
Okay, well, that's good. Give me a call.
Okay, we'll do, Pat. Thanks. I'll stop the recording now.
Okay, bye.
Okay, talk to you in a little while.
Yeah.
Oh, that's a good idea.